Okay, please subscribe my channel and please watch all videos online, and please do not download my videos. In this lecture I want to talk a little about the error of the Newton interpolating polynomial. Let me start by a theorem. The theorem says that suppose that f belong to Cn plus 1 over a and b, and it means that f and its derivative up to order n plus 1 on the interval a and b are continuous, and let Pn of x is the interpolating polynomial of f of x is the interpolating polynomial of f of x at nodes x0, x1 to xn. In fact, the number of nodal points are n plus 1, and all of these nodes are in the interval a and b. Then for all x belong to a and b, there exists a point C should be greater than minimum x0 to xn and x, and less than maximum x0 to xn and x. In fact, C should be a number between the nodal points and also x. Okay, there exists xc like this one, such that f of x minus Pn of x, it means the error. This is exactly the error, is equal to x minus x0 times x minus x1 times x minus xn times fn plus 1 of c. It means the n plus 1th derivative of f at c over n plus 1 factorial. Okay, this is the theorem. Now let me start to prove this theorem. For the proof, first let x be one of the nodal points. If x be a nodal point, it means that x be equal to something, for example xi for I equal to 0, 1, 2, n. There is no different. So it's clear that f of x and Pn of x at the nodal point are same. Okay, so the left hand side will be 0, and also in the right hand side one of these parentheses will be 0, and so this product will vanish and the right hand side will also be 0. So 0 equal to 0 happen, and there is nothing to say. Okay, so if x be a nodal point, then left hand side and right hand side of, let me call this formula as star, okay, will be 0 of star r 0, and there is nothing to prove. So we have to assume that x is not equal any of the nodal points. So assume that x is not equal to any of x0, x1 to xn. Okay? Now, put two things. First, wx equal to x minus x0 times x minus x1 and x minus xn. And also define e of t equal to f of t minus pn of t minus w of t over w of x times f of x minus pn of x. Okay? Two things true for e of t. We have the first one, e is belong to Cn plus 1 of a and b. Why? Because f is belong to Cn plus 1, and also we know that Pn is belong to, in fact this one should be Pn of t, and Pn is a polynomial of degree n, so this one is also belong to Cn plus 1, so the difference of Fn minus Pn is also, and also w is in fact a polynomial of degree n plus 1, so it is belong to Cn plus 1, so the first thing is true. Okay, now the second one, e has value 0 at n plus 2 distinct points, say x0 to xn and x. Okay, so from x0 to xn there is n plus 1 and also x. If you put, for example, some xi here and you compute e of xi, this will be this one minus this one will be 0, and also this one also will be 0, and everything is okay. And if you put x, you will have f of x minus pn of x minus w of x over w of x cancel, and minus this one, and also this one will be 0, and two our in fact facts are true. Now so by 1 and 2, okay, and using the Rolle's theorem, in fact the extended Rolle theorem, okay, we know that there exists xc, a point like xc, okay, such that xc is greater than minimum x0 to xn and x, and less than maximum x0 to xn and x, okay, such that e derivative of order n plus 1 derivative of e at xc will be 0. Now take the n plus 1's derivative from e to get e n plus 1, okay, at xc will be fn plus 1 at xc minus pn n plus 1 at xc minus, and here if you compute wt, the derivative of order n plus 1 of wt, you will get n plus 1 factorial, just n plus 1 factorial, because this is a polynomial of degree n, okay, n plus 1, and the n plus 1th derivative is just n plus 1 factorial, okay. So here I get n plus 1 factorial over w of x times f of x minus pn of x, and this will be equal 0, okay. But we know that this is also equal to 0 because Pn is a polynomial of degree at most n, and we know that the n plus 1th derivative of a polynomial of the degree at most n is 0, okay. So it just remains f of x minus Pn of x is equal to, we move this term in the right hand side and multiply here w of x over n plus 1 factorial times n plus 1 at xc, and this complete the proof. This is the end of proof. In fact, here I proved a error, in fact an error bound for the Newton interpolating polynomial. You can use this theorem if you want. Let me stop this lecture here, and I will continue with Hermite interpolation in the next lecture. Please subscribe my channel and please watch online. Thank you.